Welcome to this explainer. Today, we're diving straight into a step-by-step masterclass on reporting against the SASB iron and steel producer standard. Look, steel production is responsible for around 7 to 9% of global carbon emissions. So if you're tracking the sustainability and financial risk of these producers, these greenhouse gas metrics aren't just, compliance checkboxes. They are literally the fundamental numbers dictating the reality of the business. Let's get right into tracking production and emissions. Here's our roadmap for today. We'll start by decoding SASB for steel, then move into tracking raw steel production, quantifying Scope 1 emissions, looking at emissions limiting regulations, and finally, strategic emission reduction targets. All right, part 1, decoding SASB for steel. You might notice that the SASB standards are now under the stewardship of the ISSB, which is part of the IFRS Foundation. And honestly, this is absolutely crucial. It means these guidelines are now deeply integrated into global financial reporting. Categorized under the extractive and minerals processing sector, SASB demands total unfiltered transparency about operational scale. And why is that? Well, because you simply can't properly contextualize a company's environmental or regulatory risk without first really grasping the massive physical scale of what they're actually manufacturing. Moving on to part 2, tracking raw steel production. So this brings us directly to the SASB activity metrics table. Keep your eyes specifically on code EM-IS-000.A. This quantitative metric, which is reported in metric tons, dictates exactly how an entity must quantify their total raw steel production. But here's the catch. SASB requires way more than just a grand total. They demand to know exactly how that steel was forged. And here is exactly why that split matters so much. You absolutely must explicitly track the percentage of your production between basic oxygen furnace processes, or BOF, and electric arc furnace processes, which we call EAF. The standard points out a pretty stark contrast here. BOF relies heavily on raw iron ore and coal as its main inputs, while EAF primarily uses scrap steel and electricity. This distinction, it's paramount. It literally dictates the facility's entire energy profile, which then, of course, completely defines their carbon footprint. Which leads us nicely into part 3, quantifying Scope 1 emissions. Before we start doing the math, we really need to establish our boundaries. Scope 1 refers strictly to the direct emissions from sources that your company owns or controls. According to the standard, this includes both stationary and mobile sources. Now, for a steel producer, we aren't just talking about a couple of office buildings. Oh no. We're talking about massive, towering production facilities, plus product transportation fleets that span marine, road, and rail operations, the whole shebang. So how exactly do we calculate this under metric EMIS 110A? Well, SASB outlines 3 really vital steps for us. First up, you have to consolidate the 7 Kyoto Protocol gases, and that includes carbon dioxide, methane, and nitrous oxide. Second, calculate these using the 100-year global warming potential values. And third, and you'll want to pay really close attention here, always report your gross emissions. That means the greenhouse gases emitted right into the atmosphere before you account for any offsets or carbon credits. Ultimately, your final Scope 1 emissions number has to be presented as a single, consolidated figure in metric tons of carbon dioxide equivalent, or CO₂-e. Think of this as your standardized baseline. It's a real game changer because it allows you, as an analyst, to compare the raw, unmitigated climate impact of one steel producer directly against another, totally regardless of their specific chemical mix of greenhouse gases. Moving right along to part 4, emissions limiting regulations. Because steel production remains so highly carbon intensive, the essential question SASB asks us to answer next is this: what exact percentage of your total gross global Scope 1 footprint is actually covered under binding emissions limiting regulations? This metric is brilliant because it takes an abstract environmental footprint and instantly translates it into hard financial risk. And let me be clear, we are not talking about voluntary corporate pledges here. We are talking about mechanisms that are legally designed to strictly limit or put a price on carbon. The standard specifically highlights systems like the California and Quebec cap-and-trade programs, or the European Union emissions trading scheme. These are programs with real financial teeth. To fulfill this specific requirement, simply take the gross global emissions covered by these specific regulatory schemes and divide it by your total gross global emissions. Just a quick note, if a specific ton of emissions is subject to more than one overlapping regulation, you only count it once. The resulting percentage instantly tells stakeholders exactly how much of your core business is exposed to the rising costs of carbon pricing and strict regulatory limits.
And finally, Part 5, Strategic Emission Reduction Targets.
Under metric EMS 110A.2, your reporting actually has to go way beyond the static numbers of today. You're required to provide a really comprehensive qualitative analysis discussing your short and long-term strategy to manage those Scope 1 emissions. It's all about outlining your reduction targets and transparently assessing your actual performance.
SASB literally leaves zero room for vague environmental PR here. You must detail exactly how you're going to achieve these goals. That means explicitly disclosing the scope of the target and defining whether the goal is an absolute drop in total emissions or an intensity-based drop, like per ton of steel produced. You also need to outline your base evaluation year, your target timelines, and, probably most importantly, the concrete physical mechanisms and investments you will deploy to actually make it happen.
Which leaves us with a pretty critical thought to end on. Iron and steel are, for sure, the backbone of modern civilization. So, by transparently tracking production down to the exact furnace type and holding firm to rigorous math-backed emissions targets today, how will your facility's precise reporting shape the sustainable future of global infrastructure tomorrow? It's really not just about compliance anymore. It's about engineering the next era of industrial resilience. Thanks so much for joining me on this explainer, and I'll catch you next time.